Hello and welcome to the first video in a little series, probably 4 or 5 videos that for those of you who are new to INAV or want to give it a go. And I'm going to install it into this thing here. This is the Baby AR Wing Pro from ZOHD and I want to test fly it. And I tend to do a lot of my test flying here with INAV inside, and that gives me a lot of advantages over trying to fly it manual, which can sometimes end in disaster. Now, this video series is absolutely aimed at those of you that haven't played with INAV before. So I'm going to go through each individual step that's going to take this and a collection of electronics through to a setup system that's flying beautifully. And I'm not going to miss any steps out, and I'm going to try and explain at each step what that is about and why you set it up that way. So rather than just blast through the videos as quick as I possibly can, I'm going to take my time. So each of the videos is going to be that little bit longer. Now, in this video, I'm going to talk about 3 things really. First of all is what is INAV, explain that in relation to things like stabilizers and other stuff that you may be aware of. I'm also going to then talk about what hardware you need, so flight controllers, GPSs, talk about the things that I use here, recommendations for things to use. And then finally, we're going to very quickly go through the radio setup, the kind of stuff you need on the radio, and what I would recommend in terms of the setup. So if you're watching this first video in the series, and then you have an absolute knowledge of what INAV is, how to set your radio up, because you've maybe done it in the past, and you also know what you need in terms of hardware, you know what, you can kind of skip this whole one and whiz on to the next one, which is where we'll start flashing the flight controller and connecting everything and testing it all works. But for those of you that are still with me, who are trying to figure this stuff out, welcome. Let's get into the weeds and talk about what INAV is first of all, and why potentially you'd use it, because I know if you don't understand what INAV is, that's kind of confusing. So this slide looks a bit complicated, but don't worry about it. Here's INAV in relation to, I would say, kind of the spectrum of control, and specifically we're talking here about fixed wings. INAV itself will run on lots of different things. It will run obviously on things like quadcopters, but it'll also run on things like wings that we're setting up here, full-size planes, the V-tails, gliders even, but also things like cars and boats and stuff too. But let's just concern ourselves at the moment with fixed wing. So right over here on the left hand side, we have the simplest way of controlling your model, where the servos are plugged directly into the receiver and you control them directly via the controls on your radio. If you're not using any of the other stuff, this is how you're going to be flying. It's relatively easy to set up. You do need a little bit of skill to do it, and when something goes wrong, there is no fail-safe apart from the one that's on the receiver, which will probably disable the motor and maybe put the model into a gentle dive. That's about as good as it gets. Next level up for that, which I think lots of us did, was add some kind of flight stabilizer like this Hobby Eagle or something similar. And that gives us basic stabilization, which means that if the wind is pushing the model around, that's no issue because the stabilizer will automatically counteract for that. It makes it much easier to fly skittish models. And it also gives us things like self-righting features, brilliant for learning to fly or for giving somebody a go at the model. So if you take your hands off the sticks, the model will return to a straight and level flight, which means it's much harder to crash. Not impossible, but a lot harder. Then we've got what I would call flight stabilizer pluses, things like the ZOHD Copilot Lite. This does everything that a flight stabilizer does, but with some significant improvements because it has a GPS attached. So it'll do basic stabilization again and self-righting, but now it adds 2 really cool things. One is called auto launch, which allows you to throw the model into the sky and it will automatically catch itself, start the motor and climb strongly for the clouds. And the other one is really important, a return to home mode. This allows you to set a switch on the radio that you can flick, that will mean the model will fly back to you. Won't land, but it'll fly back to you. So if you get in a situation where maybe you have a problem with the radio or the radio link, then the model can automatically head for home, and then you don't lose the model, the battery, the receiver, any electronics you've got in there, and maybe even something like an action camera as well. So this is really handy. It's relatively easy to set up. And then we get into the good stuff. We have INAV Flight, which does everything that ZOHD Copilot Lite does, so full stabilization, self-writing, auto-launch and return to home, but it gives us some extra benefits. Basic mission flying, where you can upload a series of waypoints into memory and have it fly autonomously. We have things like on-screen display support, so information can be presented in the FPV goggles or screen if you're flying FPV. Things like your speed, height, distance, direction to home, battery status, milliamp hours used, artificial horizons, all kind of stuff. You can also get telemetry back down to the radio, and using a Lua script that we'll look at in a moment, you can have all that displayed on the screen like a virtual cockpit. So if you are in a situation where you lose orientation with the plane and you have to fly it home to yourself using that screen on the radio, you kind of absolutely can, and loads of other things too. And then I would say the most sophisticated advanced system is ArduPilot, which does all of those things plus other things like terrain following, has much more complex mission planning, it has VTOL support, but INAV Flight is the one that I use on a lot of my models because INAV Flight allows me to do those important things. So what do I use INAV Flight for? Well, despite having a massive range of capabilities, I only use INAV for these 4 things by the side of me. First of all is full stabilization. I don't use it a lot. A well-trimmed plane or wing is naturally stable and fun to fly. So I tend to turn the INAV goodness off and just use it for the other things. So I will fly a lot in manual mode. However, with smaller models that are very susceptible to be pushed around with the wind, well, you want a little stabilization, particularly when you're coming into land. So if a gust of wind tries to tip you over, having that help can be massive. The other thing that's very handy as well is the auto launch and return to home mode. I use auto launch a lot here. It means that the maiden flights that I do with the models, like this baby AR Wing Pro that we're about to build, is much safer. You can have it set up so that all you have to do is you just throw it into the air, it'll catch itself and climb to the clouds. As soon as you touch the sticks, it'll cancel out of auto launch and you are flying. So if you have problems with launching, maybe your crashes or the majority of damage is happening at the time that you're throwing your wing or your plane into the air, then auto launch is going to be a massive boon to you. The other thing that I use it for as well is that return to home mode. It's only there as an oh dear switch, as a oh blimey, something's gone horribly wrong. As you get more sophisticated and you add more equipment into your model, then the price of that model, the amount of money that you've got in the air, goes up and up and up, and you desperately don't want to lose that. And in the land of FPV, you could be flying fine, but then somebody else near you powers on their equipment and something happens to your FPV feed. You want a switch that you can hit that the plane will just go, oh, okay, right, and just turn and fly home. Again, with INAV, unfortunately, it doesn't really land as more of have a controlled crash, but what you tend to find is that as soon as it comes back, you can reacquire it via a line of sight and you can land it safely. Once it gets back above your head, it just flies in a circle by default unless you tell it to kind of land in a spiral. The last thing that I use it for is the on-screen display and telemetry. On-screen display for me, I'm a big FPV flyer, it's really important. Having information about my height so that I don't go above the legal ceiling, but also the speed, distance, direction to home, the signal strength, the battery, how many milliamp hours I've consumed, all that stuff is really important. And it's not only available on analog systems, but also all the HD systems too. And that telemetry screen on the radio is worth its weight in gold. Specifically because when you first power up the model, things like the GPS doesn't have a lock. It takes a handful of seconds to a minute or two for that GPS to get that 3D lock, so it's safe to fly. And rather than you keep having to pull your goggles down to check how many satellites you've got, you can just look at the telemetry. So let's talk about the things that you will need in order to put an INAV model together. Well, the first thing, of course, is you need the model itself. Again, I'm using a baby AR Wing Pro here from ZOHD. It's a small, compact model. My aim is to keep it as light as I possibly can. Ideally, one that's already flown is great, but as we're going to see in a moment, having the setup for the plane well is really important. INAV will fly a poorly set up plane well, but it will fly a well set up plane brilliantly. So don't use INAV as an excuse to not check the basics of the model. But don't worry, we'll come on to that in a moment. Next one, you are going to need a radio and a receiver that you can connect into the flight controller that's going to run INAV, because INAV is actually the software that runs on a piece of physical hardware called the flight controller. Now, most pilots these days would probably recommend you get something like a Radiomaster TX16S or a Radiomaster Boxer, something like that. And for new builds, I would recommend that you invest in the Express LRS system. Express LRS is an open standard protocol that no vendor owns, and you can get receivers from anybody as well as radios, which makes it incredibly flexible and powerful and keeps everybody's prices nice and keen. So rather than a vendor scalping you because you have to buy their receivers, you don't have that issue with Express LRS. You're also going to need some kind of flight controller that is going to run INAV. It's essentially a little computer on the board that also has a gyroscope and accelerometer so it can feel movement, and it's going to use that along with what it hears from the radio receiver to figure out how it needs to move the control surfaces on the wing or plane or whatever it is you have it in to make it do what you're asking it to do. Now, there are lots of different options here. You will notice that I tend to use the same ones over and over again. That's because I have used a lot of flight controllers and these ones work. Specifically in this one, we're going to use an F405WMN from Maytech. Maytech sys are the ones that I tend to use in the vast majority of builds. They are very well connected to the INAV development team and they are very well proven. And also things like the F405WMN has lots of ports that you can connect things into, so you're not going to run out of places to plug things in if you decide later on to add extra stuff into the plane that you want controlled by INAV. An optional thing, but I would absolutely recommend you get one, is a little GPS. Again, I tend to use the Maytech units here, but it doesn't have to be a Maytech unit. It's very easy these days. You can just plug it in using the 4 wires. You don't have to connect the compass up. In fact, I probably recommend that you don't. And that GPS then is going to allow you to have the positional information to give you things like the altitude and the speed, but also it's used to calculate and get the model back to you when you initiate a return to home. The GPS isn't necessary, INAV will fly without it, but for the sake of an extra £20–30, I would absolutely install one. Otherwise, you're going to not have access to about 30% of all the INAV goodness. Why would you do that for the sake of £30 when you go into the trouble of doing everything else? To set all this up, you are going to need a computer of some description running INAV configurator. We'll get into that all in the next video. You can download it, it's a free piece of software, and then you can connect your flight controller in it, and you can then load or flash the software onto the flight controller and then configure it up and test it all works on the bench before you install it in. It isn't too tricky. The INAV configurator looks almost exactly the same as the Betaflight configurator, if you've ever used that. So for lots of pilots coming from the Betaflight world into INAV, everything looks, feels and smells very, very similar, but there are some fundamental differences in terms of the setup. You are going to need some basic tools. You're going to need a soldering iron. Most of the flight controllers sadly don't come with pins installed, so you are going to have to sit and solder the pins on. If you're going to use servo style connectors to plug everything in, I would recommend doing that in a fixed wing because it allows you to sort any wiring problems out easily, but also if something gets damaged like a servo, you can just kind of unplug that servo, replace it and plug it back in. You're also going to need the basic stuff that you would normally use to help build a model, and you're going to need a little bit of time and patience, and there is also the documentation. Alongside this series that I'm creating now, there are the previous series. I've probably done an INAV for beginners once a year over the last 4 or 5 years, and I've been making INAV videos for a very long time at this point. I was involved with INAV from the very early stages. So there is lots of stuff around if you get stuck. But again, if you follow each of the steps in these videos, you should be great. So let's talk a little bit about how you set your radio up. Now, normally with wings, you'll be doing mixing and stuff on your radio. With INAV, you don't do any of that. The INAV setup on your radio is the same, whether or not you're flying a VTOL, conventional plane, a wing, a car, whatever it is. You set it up in this way. And I'll put a link down below to a video that takes you through every single step if you're not sure how to do it on something like HTX. You need your channel order. Ideally, I would recommend having an aileron, elevator, throttle, throttle rudder, AETR, which is kind of the defaults these days. If it's another order like TAER or one of those others, it isn't an issue. We can sort that out in Configurator. But I would recommend, if you're setting it on the radio, configure it using the standard wizards that are on there. Set it up as though it's a multi-rotor, because this is still a flight controller and you're still going to have the same controls. So you have the same 4 basic controls, AETR. Set your channel 5 to be your arming switch, your channel 6 to be your mode switch. I'd recommend 3-position switch for that. I'd then set up potentially 3 other channels, 1 for auto trim, 1 for auto tune, and 1 for the buzzer, so you can find the thing when it disappears in the long grass, which these things tend to do, particularly when they're small, like the baby AR Wing Pro, and you're flying in summer when the grass in the fields is nice and long. The other thing I'd recommend you do is download and install the Lua script onto your radio. Again, link below if you're not sure how to do that. That Lua script does then give us that view of the world and means that it's very easy then to figure out how it all goes together. And as you move the model on the desk, the image on the screen works. So you've got the artificial horizon. It'll also call out how much battery you've got left and all those things. It's incredibly useful. And if you're using CRSF, you're going to get that telemetry sent back by default when you configure it properly too. Last thing I recommend is do bind the receiver to the radio, obviously, using the standard way that you would normally do it. But I would potentially lower the speed down a little bit. You don't need 500 hertz. This is a fixed wing. Fixed wings don't have the kind of responsiveness and don't need the kind of responsiveness that things like quadcopters do. So I would set it down to 333 or one of those things, maybe 200, 250, and I would increase the telemetry ratio a little bit. So the way it works is by default, it's like every 128th packet that's sent to the model, you get one back. That can be quite a long gap in between each of them, and that could make the telemetry a little bit stuttery. Personally, I tend to decrease the amount of speed because I don't need it for INAV in fixed wing, and I increase the amount of telemetry so that is a little bit smoother. But if you've done those things, then your radio is set up. Again, if you're not sure how to do with any of those, don't worry. I've put links down below to the videos that go through each of those things in quite a lot of detail. Now, finally, it's time to just make sure that your model is ready to go. As I just said, having your model set up well mechanically is going to make INAV work the best that it possibly can. Ideally, a model that you've already flown is good, so you know where the trimmed positions of the control surfaces need to be. That means that then we can dial it in INAV and set them back to those specific positions that work really well. I would have a look and make sure that there is easily enough room inside for things like your flight controller and your GPS. Most modern things like this are going to have easily enough room so that you can have a flight controller, you can have a GPS of some description somewhere, and the FPV gear. There's kind of spaces for a camera and other stuff too. Make a note of where those are and have a think about how all the pieces can fit inside. Check that all the control surfaces are nice and free moving, and if you want to, you could reinforce them with tape at this point. I would also check that you know where the center of gravity is. Lots of planes like this actually have it molded into the bottom. We're going to have to hit those CG marks when we have the battery and all the electronics in, so it's worthwhile. We'll get into this in the third video, kind of laying out all the electronics and figuring out where they need to go in order to get back to those CG positions. I personally would plug the servos into a servo checker and set them at 1500 and set them up so that the angle between the servo horn and the servo rod is exactly 90 degrees when the control surface is in the right position. For this little wing, I need a couple of millimeters of up elevator just to have it flying, and that is all in the manual. Again, if you're not sure, the manual is your best place to check for this stuff. And if it isn't exactly at 90 degrees, then I normally sit and play with it and then just make a note of what that new middle channel position needs to be, because we can use that later on in the INAV setup, and we can just plug that number in. And rather than it being an iterative thing to set everything up, it's going to be absolutely right out the box. So hopefully that's been interesting for those of you that are new to INAV. Join me in the next video in the series where we'll get the flight controller out, we'll start wiring everything up, and we'll flash it with INAV, and we'll get the basics working. At the end of the next video, we'll be in a position to think about maybe moving everything and trying to figure out how it's all going to fit in the phone. Thank you for watching the video. If you watch my videos and find them useful, then please take a moment to hit the like and subscribe button. It helps the channel a lot. If you really like what I'm doing here, you can become a Patreon and support the time I spend helping others and get access to lots of exclusive benefits. Link is in the video description. Remember that all the videos on the channel are organised into playlists, so you can easily use those playlists to find all the videos on a subject that you are interested in. Add Painless 360 to your searches on Google and YouTube, and it'll help you find my content for any particular topic. Thanks again for watching, and as always, happy flying.